Force and Laws of Motion. Part 4. Third Law of Motion. In the previous video, we learned about the second law of motion and saw its mathematical representation. In this video, we will learn about the third law of motion. In our previous videos, we saw that the first law tells us how an applied external unbalanced force changes the motion of an object, and the second law of motion tells us how this applied force on the object can be measured using its mass and acceleration. Now, Newton's third law of motion says that when one object exerts a force on another object, the second object instantaneously exerts a force, which is equal in magnitude but opposite in direction, back on the first object. These two forces always act on two different objects. This means that each object exerts one force on the other object, or each object experiences only one force. To understand the third law of motion better, let us consider an example. Take the situation of a footballer kicking a football. Here, the ball moves once it's kicked. But the football also applies a force equal in magnitude on the player's leg. We can also observe that this force acts in the opposite direction of the force applied by the footballer. In other words, in any given situation, a pair of forces are acting together instead of just a single force. These two forces are equal in magnitude, and they act in opposite directions and also on different bodies. These two opposing forces are commonly known as action and reaction forces. Let us now look at two different examples to understand the third law of motion better. Example 1. Let us consider the case of a bird flying by flapping its wings. When a bird flaps its wings downwards trying to lift off, it creates a force that pushes the air downwards, which results in an equal and opposite force that pushes the bird upward and helps it to fly into the sky. Example 2. Now let us consider the case of rowing a boat. While rowing a boat, pulling the oar in the backward direction through the water results in the generation of an equal and opposite force, which in turn helps the boat move forward. In these examples, we observed that a pair of equal but opposite forces are acting on two different bodies. We can refer to one of the two forces as the action and the other force as the reaction. Like in the first example, if the bird flapping its wings downwards is the action, then the reaction is the force that helps the bird fly. Similarly, in the second example, the action is pulling the oar backwards and the reaction is the boat moving forward. This provides us with an alternative statement for the third law of motion. That is, to every action, there is an equal and opposite reaction. However, it is important for us to remember that the action and the reaction force always act on two different bodies simultaneously. Consider a situation of you trying to swim. Now, what do you need to do if you want to swim in the forward direction? In the last video, we learned about the second law of motion. From this, we know that to gain acceleration, we need to apply a force. But in which direction should you apply the force here? Is it in the direction you intend to move? No, you need to exert a force in the direction opposite to the direction of swimming. That is, you need to push against the water to move in the forward direction. When you push against the water exerts an equal and opposite force on your body. That is, the water pushes you back such that your body moves in the forward direction. Here, you must note that even though the action and reaction forces are always equal in magnitude, they may not always produce accelerations of equal magnitudes. This is due to the fact that each force acts on a different body that has a different mass. According to the relation derived from the second law of motion, F is equal to m multiplied by a, we can observe that the same force applied on different masses will produce different accelerations. Thus, each force may produce different accelerations on different bodies. Let us look at an example to understand this. Consider the case of firing a gun. Here, the gun exerts a force on the bullet in the forward direction when it fires. According to the third law of motion, the bullet should exert an equal and opposite force on the gun. This results in the recoil of the gun. However, the mass of the bullet is much smaller than the mass of the gun. Thus, the acceleration of the bullet is much greater than the acceleration of the gun. Another example depicting the third law of motion is the bouncing of a ball. When a ball is thrown on the ground, the ball exerts a downward force on the ground which can be referred to as the action force. When the ball hits the ground too exerts an equal and opposite force on the ball which can be referred to as the reaction force. This reaction force makes the ball bounce off the ground. In this case also, the action and reaction force acts in opposite directions and on different objects. In this video, we learned about the third law of motion. In the next video, we will learn about the law of conservation of momentum.